Good morning, students. In today's class, I will explain the concept of static members. We know that any class has two members. One is data member, other one is function member. So both can be made as static in C++. In our last class, we learned about how objects can be passed as arguments to member function of a class, and also how objects can be returned from the member function of a class. In today's class, we'll be discussing about three main topics. One is static members of a class, const member functions, and how one member function can be nested within another member function. At the end of today's session, you will be understanding the concept of static data member and also static member function, the purpose of const member functions in C++, and how member function can be nested. To understand the concept of static data member, let us take one simple example. Class test private int a public void read, open the bracket, close it, close the class, semicolon. When you look at this class, we can understand that the class has one data member called a and one member function called read. And the read function belongs to the category of function without argument and without return value. Later in the main function, if you create two objects, test t1 comma t2, then what happens is a copy of the member data a is created separately for t1 under the name t1.a. Similarly, another copy of the a is created for the second object t2.a. That means a copy of the member data is created with respect to every object you created out of that class. But in some situation, what happens is we don't want a separate copy of the data member with respect to every object. We want the data member to be shared by all the objects. We want only one copy of it to be created. In that case, we can make the data member as static. So whenever a data member is made as static, then a separate copy of the data member is not created for every object. All the object has to share the data member. So only one copy of the data member is created, that too for the whole class, and it is shared by all the object of that particular class. To understand the difference between a static data member and a non-static data member, if you don't write anything, then the data member is considered as a non-static. But if you specifically write the keyword static, then it becomes a static data member. To understand the concept of a static data member and a non-static data member, let us consider one simple analogy. In your house, you have your washing machine, fridge, etc. So those two items are common for all the members of your family. So those two things has to be shared by all the members. So they are considered as static data object. At the same time, your mobile number, your notebook is there for every student or every member in your house. Your mobile is there for every member of your family. In that case, mobile is considered as a non-static data member, and your washing machine, fridge, which can be shared by all, are considered as a static data members. One characteristics of a static data member is a static data member is initialized only once with an initial value of 0. So generally, first time for when the first object is created, it is initialized to an initial value called 0. After that, no further initialization takes place, and it is visible only within the class, but it is accessible. Its lifetime is the entire program. Even though it is visible within the class, it is available active throughout the program. And generally, a static data member is not associated with any object. It is associated with the whole class. That's the reason a static data member is also called as class data member or class variable, whereas a non-static data member is called as instance variable or object variables. And the scope and type of static variable must be defined outside the class. Even though a static data variable is visible within the class, it has to be defined outside the class also, outside the class only. So I will illustrate how static members are defined and how they are used in the program It's a simple C++ program. Class data, class name is data. So we have to define member data and member function within the class. The member data is declared under the access specifier private, and the member function is defined under the access specifier public. So private, static int count, and other one is int x. So here I have declared two data member, count and x. Out of that one, count is declared with the keyword static. So that becomes a static data member, whereas x is a non-static data member. And the member functions are, one is assign, the other one is display. Both the member function I'm anyway defining inside the class only. So the prototype says that void assign int a. So the function name is assign, no return value. It takes only one argument of integer type. Then within that one, I've written a statement count plus plus, and whatever value you are passing, that is assigned to the data member x. And the purpose of display function is to display the value of count. So within the display function, you write the statement cout count equal to count, end line, close the function, close the class. When you look at this class definition, you can understand that one. This class has two data member, x and count. X is non-static and count is static. Just two member function, assign and display. Already I told a static data member is visible within the class. Within the class only we can see that one count is declared with the keyword static, but it has to be defined outside the class. Another characteristics of a static data member is it is not associated with any one particular object. It is associated with the whole class. So that's the reason a static data member has to be defined outside the class with a syntax like this. Data type. What's the data type of the static data member? Int. To which class it belongs? It belongs to the class called data. Scope resolution operator. Then the static data member name count. So this is the general syntax of defining a static data member outside the class. Data type, class name, scope resolution operator, and the static data member name. So now this is the second usage of scope resolution operator. In our previous example, we have used a scope resolution operator can be used to define a member function outside the class. We also learned that a scope resolution operator helps in accessing the global value of the variable within a particular function. This is another usage of scope resolution operator. Scope resolution operator is to define what? A static data member. Now, start the main function, data D1, D2, D3. So here I have created how many objects? 3 objects, D1, D2, D3. Now what happens is D1, D2, D3 have their own copy of non-static data member. In this example, the non-static data member is X. So we have a separate copy of X for D1 under the name D1.x, D2, D2.x. For D3, it is D3.x. Whereas count is common for D1, D2, D3 because counts belong to the class called data, not to D1, D2, D3. Now see what happens when you call the functions one by one. First I'm calling the function D1.display. In the display function, what I'm doing? Display the value of count. I told you a static count is a static data member. By default, it is initialized value is 0. So output will be 0. Again, call the D2 display function. Now also displaying the value of count only. Again, count value is 0. Count value is 0. So you are displaying when you call the function D1.display, D2.display, and D3.display, your output will be 0, 0, 0. Now you call the function assign function D1.assign within the parameter within the parenthesis 10. So assign is a member function. You can call with either with D1 or with D2 or with D3. But assign function prototype says that you have to pass one parameter of integer type. So the parameter I'm passing is 10. Then now we'll see what happens when you call the assign function with D1. The control goes to assign function. Here a value will be how much? 10. Count plus plus. From 0, count becomes now 1. X and the X value, a value are passing, that is 10, goes to X. Now what happens is D1.x becomes 10. Count value will be 1. Call the same assign function with D2 object with a parameter value 20. Again, the control goes to assign function only. Now a value will be 20. Count is incremented again. Already count is 1. Now it is incremented, means count becomes 2. Now 20 is copied into X. Now D2.x will be 20. Already D1.x is 10. Now D2.x becomes 20. Count value will be 2. That you have to remember. Third time, you are calling the assign function with D3 with the parametric value 30. Now, count plus plus. Count is already 2 mean it becomes now 3 and A value will be 30. That is assigned to X. So D3 dot X becomes 30. So when you call the assign function, D1 dot X becomes 10, D2 dot X becomes 20, D3 dot X becomes 30, whereas count final value will be 3 because count is common for D1, D2 and also D3. Now what happens? Again, I call the display function with D1, D2 and D3. When you call the display function with D1, what happens? Within the display function, you are simply displaying the value of the count. What is the value for final value for count? 3. So when you call it with D1 or with D2 or with D3, you are displaying the value of count, means count value will be 3 only. So output will be 3, 3, 3. So the complete output for this function will be, when you call the display function first time is D1, D2, D3, it will be 0, 0, 0. And when you assign it, D1 dot X becomes 10, D2 dot X becomes 20, D3 dot X becomes 30. When you call the D1, now the display function, again, if it is called with D1 dot display, D2 dot display, and D3 dot display, means anyway, within the display function, you're displaying the value of count only, means count become now it will be 3. So your output will be 0, 0, 0, followed by 3, 3, 3. That's all. In the previous example, we have made only the data member as static, but it is possible to make member function also as static. When you make any member function as a static, in that case, what happens is that function belongs to the class. In that case, you cannot call that function with any object. So any function which is made as static means that becomes a common function for all the objects. So in that case, that function should be called not with any object, that can be called with the class name. Another characteristics of a static data member means a static member function is a static member function can access only the static data members of that class. It cannot access other non-static data members of that class. So this is the syntax of calling a static member function, class name, scope resolution operator, function name. So scope resolution operator is also useful in calling a static member function of a class. To understand how a static member function works in C++, let us consider a simple example program. Class data, private, static int count, int x. Just similar to a previous example, previous program. Here also the class name is data. It has two member data, count and x. Count is static type, x is non-static. And we have how many functions? Set function. So that is not started with a big keyword called static. So that becomes a normal non-static member function. Other function is display function. That's also normal non-static member function. We have one more function called display one. That I have made it as static. So now what happens is display one function is the only function which is static in nature, whether the other two functions, display and set function, are non-static. A non-static function, we know how to call it. We can call a non-static member function through any object, whereas a static member function can be called through only that class name. The thing is, a static member function can access only a static data member. In this example, which is the static data member? Count. So display one function can access only the variable count. Once after the so we have created a class, we have declared static data member, we have defined all the three member functions, set, display and display one. Then after that one, we have closing the class. One thing is, in this example also, I'm using a static data member. Whenever you use a static data member within a class, you have to define it outside the class. The syntax is data type is int, class it belongs, data, scope resolution operator, count, simple. Now we have added a static member function and we have defined a static data member. Now we'll see how a static member function is called. So within the main function, I created three member objects, D1, D2, D3. Now what happens is, D1 also can make use of which function? Set function. Sorry, D1 also can make use of set function. D1 can call display function, but D1 cannot call display one function. Similarly, D2 and D3 also can call set and display function, but display one function cannot be called with neither D1 or with D2 or with D3. display one function can be called only through data class. First function is d1.display. What happens when you call the display function with d1? You are displaying the value for x. First you are calling d1.set function. First you are calling the set function 3 times with d1, d2 and d3. It is possible because a set function is a non-static member function. When you call the set function with d1, what happens we'll see. Plus count, because count is a static data member. Its initial value is 0. Now it automatically gets incremented. Count becomes now 1. That is assigned to x. That is assigned to x means d1.x becomes 10. Sorry, d1.x becomes 1 and count value will be 1. Next one, you are calling the set function with d2. Go back. Count is already 1 mean now it is incremented. Count becomes 2. That is assigned to the x mean d2.x becomes 2. Similarly, d3.set function, when you call it, count become 3. That is assigned to x mean d3.x become 3. So now when you call the set function with d1, d2, d3, what happens? See, d1.x becomes 1, d2.x becomes 2, d3.x becomes 3. Final value of count will be 3. Now you call the display function 3 times, one with first time with d1, then with d2, then with d3. We'll see what happens when you call the display function. Display function, you're displaying the value of x. So when it call it with d1, it display the value of d1.x. What is the value for d1.x? 1. Then when you call it with d2, it becomes 2. When it call it with d3, it displays 3. So output will be 1, 2, 3. Again, you're calling display one function. Already I mentioned a display one is a static member function. It cannot be called with any object. It should be called with the class name. Which is the class name here? Data, scope resolution, display one. So display one, will call it. Inside the display one function, you are displaying the value of count mean. Final value of count will be 3, 3, 3, 3. So your output will be 1, 2, 3 followed by 3, 3, 3. So this is the purpose of a static member function, and I have illustrated how a static data member can be added to a class, how a static data member is defined outside the class, how a static member function is defined, and how a static member function is called. Another important concept in C++ is const member function. Instead of adding the word called static, if you add the word called const, then what happens is the member function becomes a const member function. The characteristics of a const member function is a const member function can access any data, member, but it cannot modify any data member. That is the reason of making the member function as constant. When you make any member function as a constant, then it's nothing but constant. It loses the power of altering the value of data member. So it can just utilize the data member, it can access the data member. It does not have the provision or it does not have the power to change the value of the data members. So this is the syntax of defining a member function of const nature. Void function name, any argument. At the end, you add the word called const. When you add the word called const, that becomes a const member function. Then we can just, that function can access any data member of the class, but it cannot alter any data member of the class. So in today's class, I'll also explain how we can write or how we can call one member function of a class within another member function. How a member functions are nested in C++. I will consider or I will explain this concept with a simple example. Class big, then it has two data member A and B of integer type, and it has three member function: read, display, and large. Out of these three functions, read function, no argument, no return value; display function, no argument, no return value; large function, two arguments of integer type, and return type is also integer type. So this class has two data member A and B and three member function read, display, and large. So all the member data are non-static. All the member functions are also non-static. It's a simple example. Now I have just mentioned the prototype of all these three functions. But now if you want to define it outside the class, whenever we are defining a member function outside the class, first you have to start with its return type. For the read function, the return type is void. The class they belong, big, scope resolution operator, and the function. I will explain how these three functions are defined outside the class. Let us start with the first function called read. Return type is void. The class it belongs, big, scope resolution, read. Then within the read function, I will input the values for the two data member A and B. C in AB. Start the second function. Return type is void. Class name is big. Function name is display. Within the function, here you see within the display function, I will write the display biggest equal to large. So within the display function, I will call another function called large. Now what happens is display function and large function are nested. Display function is also a member function of the class. Large function is also a member function of the class. But the display function in turn is calling the large function, means they are nested. So now we have defined two functions. I have to define one more function called large. Return type int, big is the class name, large int a comma b. Within that one, you declare extra variable called z. Z equal to a greater than b. If a is greater than b, then which is biggest? A. Return the value of a. Otherwise, return the value of b. Whatever value that is returned, that is stored in the variable called z. Return the value of z. I think you already studied that when a greater than b, question mark a colon b. That's a conditional operator. How it works? First, a greater than b is tested. If a value is greater than b, then a value is assigned to yes. If a is not greater than b, means then b value is assigned to z. So now, whichever value which is assigned to z, that will be the biggest among a and b. That's all. Next, in the main function, I create only one object called b, of which class big. Call the b dot read. There you input the value for a and b, two number. Then b dot display. When you call c, in this here, I'm not calling large function separately, because when you call the display function, which in turn calls large function, that's the purpose of nesting of function. So here, which one? Display function in turn is calling large function, means display function is nested with large function, or display function and the large functions are nested each other. The examination, generally one simple question will be from the topic static data member or nesting of member or const member function. Illustrate with an example static member data in C++. You can consider the same example that I have given in this video lecture. Illustrate with an example static member function. Explain the significance of const member function. Illustrate with an example nesting of member function. So generally one question out of these four will appear in your exam. Let us revise what we have studied through some simple multiple choice question. Static members are also known as object members, class member, instance member. None of these. Correct answer is class member, because any member of static in nature belongs to the class, not for any object. Static members are initialized to 0, 1, user defined value, none of these. By default, it is initialized to 0. A. Static member function is called with class name, object name, either A or B, none of these. It is called with generally, not generally. It should be called with only class name, A. Number of copies of static member created. We know that a static member is only one copy of it is created, which can be accessed by any object. So number of copies created will be 1 for B. Member function which cannot alter the member data is declared as forbidden, const, static, private. The correct answer is B. Okay, students, in today's class, I covered 3 different topics. One is static member. Member could be both data member and function member. Const qualifier, const member function, and the concept of nesting of one member function within another member function. The static data member is a very, very important concept in C++. So with this, I will conclude today's class. Thank you.